The engine. The engine is the heart of an agricultural tractor. In fact, it has to not only provide the mechanical power necessary to generate the tractive force to the wheels via the transmission, but it must also transmit the motion to the power takeoff in order to operate the external implements. It must, furthermore, provide hydraulic power for the front and rear lifts, for the external implements, for the hydrostatic steering, and all the other integral hydraulic systems. What is required of a tractor engine? The engines used on agricultural tractors differ from those intended for truck units by several typical characteristics, deriving from their differing end uses and requirements. In particular, maximum reliability. Stoppages due to damage can, during certain periods of the year, compromise the quality of the harvest. In fact, basic farming jobs, such as ploughing, preparation of seed beds and harvesting, must be completed within a period of 2 to 3 weeks during favourable weather conditions. To be constrained to postpone such work means frequently compromising the results of the work, and in any case certainly causes a greater expenditure of energy and man-hours. Economy of operation. Contrary to cars and road trucks, which do most of their work at cruising speed, which requires a low energy usage, the tractor is called upon to produce almost optimum power very frequently and for long periods, which means that the fuel heading is a determining factor in operating costs. Resilience of operation. Long working life, at least 10,000 hours. Automobile engines have a lifespan of about 3,000 hours. Long periods of operation, even in a stationary position with heavy loads and at engine outputs close to maximum. Operation in dusty surroundings. High adaptability to all atmospheric conditions, very hot and very harsh climates. Robustness, since the engine structure must be able to withstand unexpected overloads caused by irregularities of the ground and by the requirements of the work. Simple to service, because it must to a large part be done directly by the farmer. Immediate starting and rapid power availability. Minimum overall size so as to facilitate handling and visibility. The most appropriate response to such requirements is provided by the diesel engine, used in agriculture for about 60 years. Same has used diesel engines on its tractors right from the start. Compared to spark ignition engines, this is more suited to use on agricultural tractors because it supplies much higher engine torques due to the very much higher pressures built up during the operating cycle. Its RPMs are lower, hence it requires a lower reduction ratio on the transmission and guarantees a much longer operating life. Its specific consumption is lower by 30%, offering a much greater economy of operation. Performance. We shall try to evaluate the performance of a diesel engine for agricultural use and how the parameters which define it are collated and interpreted. What parameters are used to evaluate performance? Engine torque. To tighten up this screw, manual effort is insufficient. Here then is a spanner, which amplifies the manual effort by means of its length. The work of the farmer, besides tightening screws, consists in towing heavy working implements. For this, it is necessary to have a high tractive force at the tractor's wheels. To make the wheels turn is like tightening a screw. A torque of similar intensity is generated in this case by the engine. The pressure exerted on the pistons by the combustion gases is picked up by the rod and, via the crank, causes the drive shaft to rotate. The engine torque is nothing other than the product of the force transmitted by the rod over the length of the crank. It being a question of a force multiplied by distance, the units of measurement of engine torque are Newton meters or kilogram meters. Capacity. The quantity of actual work which the engine produces in a unit of time. This is given by the product of the engine torque for the speed of rotation of the drive shaft, unit of measurement, kilowatt and horsepower. Specific consumption. The quantity of fuel which is burnt in 1 hour for every kilowatt of output produced. The units of measurement are grams per kilowatt per hour or grams per horsepower per hour. In practice, a 100 horsepower engine certainly consumes more fuel than a 50 horsepower engine. However, it is possible for each horsepower unit of a 100 horsepower engine to be obtained with a lower fuel consumption, that is, with a lower specific consumption. The specific consumption, therefore, allows the efficiency of operation of even very different engines to be compared. Therefore, it is even possible for two engines, one of 100 horsepower and the other of 110 horsepower, to consume the same amount of fuel if the 110 horsepower one has a lower specific consumption than the 100 horsepower engine. How are the performance figures and operating characteristics collated? Engine torque, output and specific consumption are measured by carrying out engine tests on the bench. The technique used is that of running the engine at maximum fuel feed, at full throttle, and of applying increasing loads to the flywheel by means of suitable brakes. On increasing the load, the revolutions are reduced, and for a certain figure of speed of rotation, measurements are taken of the engine torque and the fuel consumption, from which it is then possible to calculate the output power produced and the specific consumption. Once these data have been obtained, a graph is plotted with the values for engine torque, output power and specific consumption according to the RPM. These, therefore, give the operating characteristic curve of the engine at maximum fuel input. What are the normal testing standards? The testing standards for performance figures of the most disparate engines are those established in West Germany by the German Standards Institute, DIN, and in the USA by the Society of Automotive Engineers, SAE. In Italy, for engine approval purposes, the tests of the Automobile Standards Unification Committee, CUNA, are the recognized ones. All these standards are based on the measurement of the performance figures of the engine alone, whose output power is recorded on the test bench. Tests on complete tractors are, on the contrary, carried out in Europe according to the standards of the OECD, which is the organization of the European Economic Community which has set up codes and standards for testing agricultural tractors within the European sphere. Standard DIN 7020. This is a test of the engine with all the standard accessories necessary for its normal use: air filter, discharge gas exhaust system, water pump for water-cooled engines, cooling fan and alternator not under load. By means of corrective formulae, the measurements are always referred to temperature and ambient pressure conditions of 20 degrees centigrade and 1013.25 millibars respectively, for the purposes of being able to compare test results conducted in different places and under different meteorological conditions. CUNA standards. The tests carried out according to CUNA standards are essentially equal to those conducted according to DIN 7020. Only the corrective formulae for relating the performance figures to the standard conditions vary. The differences between the results of the tests carried out according to the two standards are generally within plus or minus 1%. Standards SAE J270. These differ from the DIN 7020 standard essentially because they are carried out on engines stripped of their necessary accessories. For this reason, the power output measurements, taken according to the SAE standards, are generally about 10 to 15% higher than those conducted according to the DIN standards. How are the characteristics curves interpreted? Let us now try to analyze by way of example the characteristic curve of the 1004 turbocharged engine, which is fitted to our 88 horsepower medium-range tractors. Engine torque. The torque reaches its maximum value at 1,350 RPM, the speed at which the engine has the best overall efficiency. The working requirements demand that the torque maintains its high level throughout the whole field of engine operation. Beyond 2,500 RPM, the overall efficiency declines rapidly, and with it also the torque. Power output. Power output increases with the RPMs up to 2,500 RPM. At speeds above 2,500 RPM, work is not productive, as the output power and torque fall to inadequate levels. Like the torque, it is necessary for the output power also to be maintained at a high level over a wide range of operation. In the example selected, between 1,350 and 2,500 RPM, the output power is between 70% and 100%. This is the recommended range of use. Within such a range, it is advisable to use the engine at a speed close to that of maximum output power, when it is necessary to take advantage of full engine power, heavy ploughing, work with power harrow or cultivator. It is advisable, on the other hand, to use the engine at intermediate speeds, 1600 to 1800 RPM, in order to contain consumption as much as possible when the tasks to be done are light. It is of interest to note that in order to obtain 90% output power, 1900 RPM are sufficient, which is 600 RPM below the maximum output speed. Specific consumption. For the farmer, it is of the utmost importance that the engine should have a low specific consumption throughout the range of operation, for economy of use at whatever speed is required by the work being carried out. The 1004 engine presents the minimum specific consumption within the maximum torque speed. Consumption is only slightly higher at maximum output speed, which at 157 grams per HPH represents a record performance. The farmer requires a further important performance from the engine, resilience, which can also be similarly quantified by means of the characteristic curve. What is engine resilience? The farmer wants an engine which is capable of functioning in a stable manner over a wide range of rotational speeds. In fact, if during some demanding work the engine encounters an overload and reduces its RPM, the engine itself must be immediately capable of producing a greater torque in order to counter the overload, and of returning the engine as rapidly as possible to the original speed once the overloading has ceased. On the graph of the 1004 engine, from observing the torque curve, it will be seen that on reducing the RPM down to 1,350 RPM, the torque increases, and the engine is able to withstand even greater loads. Also shown on the same graph is the zone in which functioning becomes unstable, because the torque, instead of increasing, decreases as the RPM decrease. At every overload which causes the RPM to decrease down to the unstable running speed, the driver is forced to change down in order to return the engine to a stable running speed. For the purposes of resilience, therefore, two parameters are important. The first is the extent of the stable functioning range, which must be as broad as possible, at least 35% of the maximum output speed, and within which it is possible to operate by varying the RPM without changing down. Any engine which obliges the driver to change down at a minimum variation in RPMs is not resilient. The other parameter is represented by the additional torque which the engine can generate on reducing the RPM down to the maximum torque speed, and which is quantified by the reserve torque. That is, by how much the torque increases compared with the value it assumes at maximum output speed. The reserve torque on a good engine should never be less than 10%. In the case of the 1004 engine, an impressive reserve torque figure of 28% has been calculated. The Same engine. SAME does not go to outside suppliers for its engines, but designs and produces its own, according to the specific requirements of their agricultural use, without having to adapt for heavy agricultural working conditions engines designed for other uses, trailer, trucks, industrial, etc. SAME engines are designed together with the complete tractor, from which will be formed a harmonious power source and at the same time an important part of the structure. SAME engines are in fact all self-supporting, and their robustness allows the coupling of implements such as the front lift and a loading shovel. Furthermore, the simultaneous design of the tractor and of its engine guarantees that the latter is of the ideal size and performance as required by a certain type of use in a very precise power range. In short, SAME engines are ideally designed size-wise for the specific use of the tractor which they're going to equip, and they integrate perfectly with all the components and systems of that tractor. Modularity and standardization of components. The design philosophy of our engines is based on these two concepts. Modularity has enabled engines of different power classes to be produced with from 2 to 6 cylinders, starting from the same modules. Standardization of components means that more than 80% of the parts forming the whole series of our engines are perfectly interchangeable. This brings with it reductions in the costs of parts stocks, simplification of parts management, ease and rapidity of servicing. SAME air cooling. The extremely simplified maintenance, checking the conditions of the belts and periodical cleaning of the fins, guarantees minimum costs, minimum standstill times for the tractor. The simplicity of the SAME air cooling plant, comprised solely of a fan kept rotating by the engine via a double rubber belt, makes the risk of breakdown practically insignificant. Less inconvenience, less maintenance costs, greater security and reliability. The efficient discharge of the heat from the cylinders to the cooling air is an essential condition for preventing overheating of the engine. To this end, in SAME engines, the heat exchanger surface of the finning has been provided so that where the temperature is highest, at the cylinder heads, this area is greatest. The finning on the cylinders has a much greater heat exchanging surface on the right-hand side of the engine, where the greater heat is generated. This has enabled the operation of the engine to be pushed to the higher temperature cycles without any risk of localized overheating of the engine, with the advantage of a much higher thermal efficiency, resulting in an exceptionally low specific consumption. So as to guarantee uniform cooling of the various cylinders, SAME introduces pressurized air by means of a cooling fan into the duct. The leap in pressure, compared with the outside ambient air, guarantees the passage of the air between the fins, without it following its own preferential path, which may reduce the uniformity of cooling. Cooling fan with rear stator. The arrangement of the stator in a position behind the fan instead of in front of it, as in the traditional manner, permits the air, put under pressure by the same fan, to be distributed in a uniform manner, and to ensure that there is an equal flow of cooling air around all the cylinders. Efficient, uniform cooling of all cylinders. The cylinder finning acts as a thermostat. In fact, it naturally regulates the heat exchange unit with the air, according to the external temperature, so as to maintain the service temperature at a constant level independently of the climatic conditions. Adaptable to every climate. Absence of any kind of mechanical thermostat, and so as to reach the working temperature in a short time. Rapid power availability. Mixed cooling of cylinders. Forced air circulation cools the cylinder heads and upper sections, whilst pressurized oil cools the bottom sections of the cylinders by circulating around them in suitable cavities cast in the cylinder block. Inside, a powerful jet of oil under pressure directly cools the pistons and the cylinder walls. This is the most advanced cooling system in existence today on the diesel engine market. The improved uniformity of cooling of the cylinders guarantees their perfect cylindrical shape, giving improved piston cylinder tightness for greater engine efficiency, less wear, possibility of operating under prolonged load conditions, stationary use with a high power requirement at the power takeoff, lower heat expansion and related stresses, a much longer working life, very high thermal efficiency, since the engine can function at the most convenient temperatures. Sulfuric acid, the undesirable side product of fuel combustion and mainly responsible for cylinder wear, condenses on the walls for so long as the temperature remains below 65 degrees centigrade. In the SAME air-cooled engine, this temperature is reached 4 times more quickly than in a traditional water-cooled engine, resulting in less wear, a much longer service life. Each thermodynamic cycle has a thermal efficiency. The higher it is, the higher is the mean operating temperature. In this respect, the SAME engines achieve high mean temperatures in the thermodynamic cycles without overheating, as the heat is effectively discharged by means of the accurate geometry of the finning and their ample heat exchanging surface. Engine cooling on the right-hand side. The cooling air is captured on the right-hand side of the engine where the greatest heat develops, thus giving greater cooling efficiency, where the injection pumps are located. Improved injection output, since, due to the cooling of the pumps, the fuel is pumped at a lower temperature and therefore at a greater density. Air cooling of the engine has permitted the design of engines with independent heads extremely easily, so that there is improved tightness of the cylinders due to the more precise centering of the heads on the cylinders, reduction of engine servicing times and costs, reduction in costs of parts stocks. Soundproofed air duct. This provides better soundproofing. Dry air filters. The dry air filters are preferable to oil bath cleaners since they provide better protection of the engine, with filtering efficiency from 2 to 20 times greater. The oil bath cleaners have a maximum efficiency of 99% with a 1% residue. Air filters have a minimum efficiency of 99.5% and achieve up to 99.95% with a residue of from 0.5% to 0.05%. Constant filtering efficiency with RPM variations and tractor angles. Filtering efficiency independent of the state of cleanliness of the filter. If the filter is very dirty, the engine power drops, but not the degree of filtering. Spiral induction pipes. These allow for an eddying movement to be imposed on the air on its input to the cylinder, which markedly improves the filling of the cylinders, high suction efficiency, by building up greater power, furthermore improving the mixture of air and fuel, giving lower consumption, lower smoke emission due to complete combustion, less incrustation of carbon residues, ease of starting from cold. Technologically advanced injection system. The injection system has been designed in a completely new way by applying highly advanced technological solutions. Single-cylinder immersed pumps. Our tractors are equipped with injection pumps immersed in the cylinder block, which offer important advantages. Being directly controlled by the camshaft, they do not require a secondary shaft with the relevant gearing to operate them, thus giving greater mechanical efficiency, less friction loss, greater speed of actuation, complete protection against accidental knocks, being immersed in the cylinder block. Being actuated by large-size cams, the speed of injection is very high, and therefore injection times are very short, even at different engine speeds. Better combustion, more restricted fuel consumption, a livelier engine, less smoke emission, absence of supplementary filter, hence less sensitive to impurities contained in the fuel. Scarcely sensitive to any water possibly present in the fuel, hence no risk of seizing up. Each cylinder is fed from a single immersed pump actuated by the camshaft. This solution has contributed to the compactness of the engine length and to the uniform distribution of the load on the camshaft, by permitting also the insertion of two brackets for each of the main bearings, so as to reduce shaft bending to the minimum. To the characteristic advantages of the immersed pump can be added the possibility of operating the engine even in the event of damage to one pump, greater engine modularity, thus modifying servicing costs and time. The same pump is interchangeable on all engines of the same family, reduction in the stock of parts. A return valve stops the injection, makes the fuel return from the injector to the pump via the same delivery pipes until the pressure drops to 70 bars. At this point, the valve closes and the delivery pipes remain full of fuel at 70 bars, ready for immediate injection at the next cycle. Rapid, precise injection. Lively performance. High pressure in the delivery pipes, even at low speed. Injection tailbacks avoided. Very short, equal length injection pipes. The adoption of very short pipes markedly reduces the pressure waves, similar to water hammering, which can form by the effect of the extremely rapid sequence of fuel delivery under very high pressures, and which can make combustion irregular. Optimum combustion, greatly reduced consumption. The equal length of the pipes guarantees uniformity of fuel feed to all the cylinders. Regulator. The regulator is mechanical with counterweights. Simplicity, robustness, safe operation. It is formed from a module independent of the engine in a well-protected but easily accessible position, and can be fitted and dismantled easily and quickly. Easy servicing and calibration. It is operated from the camshaft and rotates at high speed, the same as the engine, thus allowing the use of more compact counterweights, giving a more prompt response. It incorporates the automatic supplementary fuel feed device for starting the engine. The control rod, made of special alloy steel, runs on suitable rollers. Greater precision and sensitivity of regulation. The engine stop control acts on the regulating rod rather than on the regulator kinematics, thus allowing the engine to be stopped at any speed. Possibility of stopping the engine even at maximum speed, with the advantage of prompt action in emergencies. An anti-oscillation system contains the speed variations to within plus or minus 20 RPM during idling. Reliability in harsh climates. For very harsh climates, the engines are fitted with thermoignition, preheating plugs in the induction manifold, and are arranged for the fitting of an electric preheater for the oil in the sump, so as to guarantee proper lubrication immediately on starting the engine, which is a particularly wise requirement in turbocharged engines. Integral lubrication. The lubricating oil for all the engine parts, crankshaft, camshaft, rocker arms, runs in channels worked into the cylinder block and in the rocker arm control rods. No tubing inside or outside the engine. Reduction of the overall external size of the engine. Elimination of any possibility of breakage or loss. Reduction in maintenance costs. The lubricating oil circuit is provided with a cooler. In order to maintain the oil temperature at optimum values, in certain climatic conditions, a thermostat can be fitted to the cooler, which allows the oil to be cooled only when beyond a preset temperature. Reliability of the lubricating system, even during the most demanding uses. Maintenance of the physical chemical properties of the oil for optimum lubrication. pistons are of a light aluminium silicon alloy. Play between pistons and cylinders remains constant under temperature variations. Less friction between pistons and cylinders, improved heat dispersal, less incrustation, livelier engine performance since the lightness of the pistons allows for more rapid acceleration, longer service life. In the new engines of the 1000 series, the highly accurate design of the profiles and the use of special materials have permitted a reduction in the number of piston rings from 4 to 3. The bottom sealing ring has a sharp-edged profile which guarantees a perfect oil seal during the initial operating hours. On later running in, the edge rounds off and fits perfectly against the walls. The reduction to 3 piston rings has permitted shorter, lighter weight pistons to be made, with advantages for the liveliness of the engine and rapid acceleration. Finally, the top sealing ring cavity on the turbocharged 1000 series engine is made with a high temperature resistant cast iron ring holder, so as to avoid wear of the actual cavity. Valve seat inserts, made of molybdenum, chrome and vanadium cast iron with a low carbon content, in order for it to have a toughness close to that of steel and a high wear resistance, particularly at low temperature. Better long-term tightness. Engine shafts with discharge grooves. In the mechanical parts, high stresses always exist in conjunction with sudden variations in shape, giving a concentration of tensions which can cause cracks and fractures. In order to avoid this nuisance, circular discharge grooves have been worked into the joint profiles of all the crankshafts on the latest series of engines, which drastically reduce such tensions. The rolling process used for creating the discharge grooves provides advantageous surface hardening. The gearing of the timing mechanism has helical toothing, less loss of power through friction, quieter operation, counter-rotating weights, models with 4-cylinder engines. In the 4-cylinder engines, the crankshaft and the parts in reciprocating motion generate alternate inertial forces of the second order. In order to compensate for such forces, the 4-cylinder engines are provided with 2 counter-rotating weights, which rotate at twice the engine speed, that is, at the speed of the alternate forces of the second order. Less vibrations, less strains on the structure, greater comfort. Robustness. The great robustness of our engines, on the 70 horsepower engines, also the oil sumpers of cast iron, makes them self-supporting. That is, they are capable of supporting even the application of front loaders. Easy access to and servicing of the engine. On all models, access to the engine for inspection and servicing is easy from either side, as the whole bonnet folds forward on the tractors in the low range, or the side panels are removable on the medium and high range tractors. In particular, the extremely rational design has meant that ordinary servicing can be carried out all from the right-hand side, with the dipstick, the filler pipe, the oil filter and drain, the lubrication circuit's thermostatic valve, the delivery and injection pumps, the regulator, the cooling fan, and the battery are located. Turbocharged SAME engines. It is the wish of every farmer to have at his disposal high-powered engines, but of compact size, so as not to penalize the handling of the tractor. What are the methods for increasing engine power? Turbocharging is the sole method of increasing power efficiently whilst maintaining a compact size and weight and without reducing engine reliability. The other main methods, which do not, however, allow for achieving these results, are by increasing cylinder capacity, by increasing both weight and dimensions and possibly even the number of cylinders, by increasing the maximum speed of rotation. This increases the mechanical stresses on the engine and lowers its volumetric or induction efficiency. SAME, always promoting research into better performances and greater driving power, has turbocharged these engines, 90, 150, 170, for which a high specific power has enabled the overall dimensions of the tractor to be kept compact. SAME, on the other hand, has opted for those technological solutions, moderate turbocharging, even on the 170 horsepower with intercooler, which guarantee engine reliability and a long service life. How does turbocharging work? By compressing the air before introducing it into the cylinders. What are the effects of this? Increase in the density of the air and therefore of the amount of air contained in the cylinder. The engine can be supplied with more fuel and generate more action from the combustion. Increase in the mean pressure of the engine's operating cycle. Results: increase in power without increasing the cylinder capacity, the weight, the size, or the maximum speed. Finally, increase in the specific output power, which is the power per unit of cylinder capacity. Improvement in engine resilience. Lower specific consumption compared to an engine of equal power which is not turbocharged. Compensation for loss of power at higher altitudes. Less pollution due to better combustion, less smoke emission associated with the improved air-fuel mixture. Quieter. Why does the specific consumption improve? Turbocharging increases the volumetric or induction efficiency of the engine. That is, it improves the filling of the cylinders, with the benefit of the power that can be generated from the fuel burnt. Power increases more than fuel consumption, thus giving rise to lower specific consumption figures. How does turbocharging work? By means of a centrifugal compressor, which compresses the air in the induction pipe before introducing it into the cylinders. The compressor is nowadays, in the majority of cases, activated by a fan driven by the exhaust gases. Turbo compressor, a solution which offers the advantage of not taking any power from the engine, but of recycling the engine contained in the exhaust gases, which otherwise would not be used. Turbocharging with a turbo compressor leads to increases in power of up to 30%. The designer has to give the engine parts more ample dimensions and take into account that the greater power produced entails the removal of more heat. For this reason, the cooling system has to be enlarged and great care taken in the manufacture of the valves and piston rings, in the choice of the materials used for them, and in controlling the temperature of the lubricating oil, which must also lubricate the delicate moving parts at more than 100,000 RPM of the turbo compressor. What is the intercooler? During compression, the air, besides increasing its pressure and its density, heats up. Its density, and hence the power generated by the engine, would be greater if the air were not heated up. This penalizing situation is felt particularly in cases of forced turbocharging, 1 bar and beyond. Therefore, provision is made for cooling the compressed air before it is introduced into the cylinders. Intermediate refrigeration, intercooling, with the result that the density and the power generated by the engine are increased. The reliability achieved by the turbocharging systems makes their use continually more widespread, which offers advantages from many aspects. Better utilization of the engine, which offers lower specific consumption and greater resilience. Increase in the power within the confines of one single family of engines, with the advantage of standardization of components and simplification of spares, management and servicing. Production of greater specific output power, with compact size, benefiting visibility and tractor handling. Excellent performance. Great resilience, torque reserve up to 28%. Possibility of surmounting overloads without having to change down, thus contributing to a reduction in consumption. lively engine acceleration, a wide field of use of the engine. The stable operating range extends from 1,200 to 2,200, 2,500 RPM according to the model. High drive torques, capacity to surmount even the heaviest loads, extremely low specific consumption figures, all below 168 grams per horsepower hour, with peaks below 160 grams. These figures are confirmed by official ratification tests to DIN 70020 and are absolutely the lowest in the field of tractor production in the world. The majority of engines of other constructors have certificated specific consumption figures in the order of 180, 190 grams per horsepower hour. What significance do these data have in terms of fuel savings? On the basis of 1,000 hours use at maximum output power, compared to a competing tractor of similar power with a greater specific consumption, our tractors offer a substantial saving in fuel. SAME, comfort and safety. Driving an agricultural tractor is definitely very demanding work, which can become even fatiguing and stressful under certain conditions if the tractor is not endowed with adequate technical and operational features. Fatigue and stress, besides compromising the health of the driver, can also reduce productivity and even compromise the successful accomplishment of the work. For these reasons, clients are paying ever greater attention to aspects relating to comfort and safety. And very often, this is the deciding factor which determines the purchase. For the purposes of productivity and of quality of work, therefore, attention to the comfort of the driver by optimizing the man-machine relationship represents, within the chain of agricultural work, a link no less important than the performance of the engine, the transmission, or the hydraulic system. SAME has, for a number of years, made a conscious choice in favor of a greatly developed degree of comfort on all its models. For some models, however, it has been necessary to keep to a more basic level of comfort, either because they are low-powered models or because they are tractors intended for working in cultivation where dimensional features are overriding and hence counter to having a sophisticated driving cab. Tractor with footboards. Below the 50 horsepower, the driving position is traditional but sufficiently spacious to allow the driver to operate the various controls with ease. from 50 to 60 horsepower, the larger dimensions of these models have enabled us to achieve a comfortable driving position by means of wider, more spacious footboards, complete encasing of the transmission, keeping the driving position particularly clean, a more ergonomic layout of the controls, a driving seat with longitudinal and suspension sensitivity adjustment. From 70 to 80 horsepower, we offer a driving cab with a completely innovative interior, which includes everything found on platform tractors except for the actual platform itself, which is incompatible with certain work. Laterally located gear levers, suspended pedals, encased gearbox and transmission housing, driving seat with 3 adjustments, suspension sensitivity, longitudinal and height positioning, entire driving area mounted on strong anti-vibration mountings. (60 to 75 horsepower orchard tractors). Also in this family of tractors, for which the dimensional limits are extremely severe, we have been able to offer an extremely well-designed driving position with spacious footboards, encased gearbox, suspended pedals, adjustable seat, adjustable steering wheel. Platform tractors. A perfectly flat platform for the greatest freedom of movement, giving easy access to the driving seat. It is suspended on 4 anti-vibration mountings, eliminating every vibration, and covered with anti-slip, easy clean rubber matting. The layout of the controls has been designed according to improved ergonomic research. All levers have been positioned beside the driver, thus giving a completely free driving position. They have been arranged so that those in most frequent use are on the right-hand side: gear levers, hydraulic lift and auxiliary hydraulic levers, PTO control, whilst those which are less used are on the left: four-wheel drive engagement lever, parking brake, synchronized PTO engagement. So as to eliminate all obstacles, the pedals are of the suspended type. The steering wheel can be angled to the most comfortable position for the driver. Exit and entry are made easy by broad steps, suitably angled, designed so as not to catch on the ground during deep ploughing. Furthermore, the handholds are large, within easy reach, and are positioned where the hand instinctively falls. There is ample visibility of the 3-point hitch, thanks to the tank being located under the platform. The controls. Comfort is also achieved by reducing the effort which the driver has to exert in order to operate the various controls. For this reason, on all our models above the 50 horsepower, we have brought into general use the hydrostatic type of control, clutch and brakes, and hydraulic servo controls, steering and PTO engagement. For easy, precise steering, particularly for road transport, we use a reactive type of hydrostatic steering, which eliminates the irritating drift effect associated with some types of hydrostatic steering, and the steering wheel automatically returns to the central neutral position after a turn. The dashboard. The complete instrumentation and easy-to-see warning lights enable the operator to check continuously the proper functioning of the tractor. The cab. Our cabs are all original designs to harmonize with the tractor. They have been approved as quiet, safety cabs to meet the most stringent international standards. They offer complete visibility due to the all-round glazing. 2 large reversing mirrors allow easy checking of implements being carried or towed. Soundproofing of the platform has been achieved by a triple layer comprising a hard rubber matting with anti-slip relief finish over bituminous rubber and a foam material with high sound-absorbing qualities. Furthermore, a thick insulating, sound-absorbing partition prevents heat and noise from the engine penetrating into the cab. Finally, the lining of the inside of the cab walls is in sound-absorbing materials used in automobiles. Even the molded instrument panel is in sound-absorbing, expanded polyurethane. The two wide doors are full height and have a wide opening angle for easy access. Grab handles are placed within easy reach to further improve access. On the medium and high ranges, when the doors are open, they do not protrude beyond the overall dimensions of the tractor, thus making it extremely improbable that they will knock against obstacles whilst moving with the doors open, as when working in the farmyard, when, for example, clambering in and out is likely to be more frequent. Furthermore, the gas strut opening means that in the event of knocking against any obstacle whilst moving with the door open, the door affected will close without suffering any damage. The anatomically designed driving seat with folding armrest has 4 adjustments. Sensitivity adjustment for adapting the suspension to the weight of the driver, position adjustment longitudinally depending on the leg length of the driver, height adjustment, adjustment of the backrest angle. The interior finishing is in restful colors for a comfortable working environment. Positioned in the roof is a stereo radio cassette, the internal cab light and a digital clock. Air conditioning. Pressurized ventilation. The air, filtered for dust, is fed in by a 3-speed fan via swivel diffusers. Heating. A powerful heating unit guarantees a comfortable internal temperature even with sub-zero temperatures outside. Fresh air even in torrid climates. On the larger tractors, the air conditioning unit maintains an internal air temperature close to the optimum for the human body, transferring the cab into a refreshing environment during the hot summer hours. Pressurization. In order to prevent the ingress of dust, the perfect closure of the doors, the side windows and rear hatch, and the protective covers of the rods on the various controls all guarantee the cab module is completely tight against dust and dirt, and hence at an optimum pressurization level of between 3-4 millimeters water gauge, which is below the maximum allowed by law in order to avoid the driver suffering discomfort in breathing. Safety. The total design of the Same tractor has been carried out with a view to safety in all its aspects. Safety in the driving seat. Safety cab and safety belt. No danger in the event of overturning or in a road accident. Cab with 2 doors, windows and roof hatch, all opening. Ease of exit in emergency. Safety of access to the driving seat. Broad steps, anti-slip and suitably angled. Large, easy to grasp handholds. Flat platform, obstacle-free with anti-slip surface. Safety in the use of the tractor. Starting the tractor only with gears in neutral. No risk of accidental moving off. Protection of all moving parts and all hot parts. No risk of accidents. Reactive type hydrostatic steering. Accurate, safe steering even at high speed. Hydraulic lift with non-return valve. Prevents accidental drop of implements with engine off. Brakes on all 4 drive wheels. Precise, powerful, predictable braking. Emergency indicators. Safety in case of unforeseen stopping on the highway. Elegant styling, made in Italy. Power, comfort and safety are expressed in all our models by a functional line which characterizes the typically sporting elegance and displays the salient personality traits of the Same mark.